All right, guys, so in this one, we're actually going to go through and graph this linear inequality. The last time around, I talked about what a linear inequality kind of looks like in general. And then I wanted to make sure that we could check to see if my solution, if I could tell if a point was in that solution. So there is a graph of this that includes some shading. And if my points are in that shading, then it's in that set. So we're going to use that information to graph this thing. All right, so first, let me just say that the first step you need to take is to actually graph the equation. All right, so if I were to say steps over here, number one, graph the line. So I want you to recognize that this is a line in slope-intercept form. I'm going to very quickly sketch that on here. So I know my y-intercept is 1. I need to go up 2 over 1, up 2 over 1. There's another point. So I could, in theory, draw a line. And notice that I made it a solid line. I made it a solid line because you see this thing right here? If you remember from before, whenever it includes that equal to part, it's a solid, right? So things like this and this mean solid. And then for our purposes here, when you don't have that, that's going to mean a dotted line. And we'll do an example of that also. But since this thing right here is an equal to part, I made a solid line. So that's the first part. I'm able to graph it. That's almost like my boundary line. Notice that I could have either things over on this side, or I can shade this side. I need to make sure that I shade the right side, right? So for here, I'm going to say shade the correct side. Because it's an inequality, you need to shade some. With a star, I'll say use a test point. Now, what do I mean by that? Well, if this is my boundary line, either these are going to be my solutions or these are going to be my solutions. If I choose a point over here, and I like to use, basic points here. In fact, what I really like to use better, and let me erase my line so I can draw that better. If I were to draw my line again, okay, that's a little bit better. I like to use points that are going to be easy to calculate. So I can choose any point over here, and if this thing makes it true, then I know this is my solution, and I'll shade this side. If I choose a point from over here and it's not true, then this is not the side, and I must shade this side. You can use any test point you want. I'm going to use 0, 0 usually, because it makes the math easy. So what do I mean by that? Let me test it. If y is greater than or equal to 2x plus 1, I want to use the point 0, 0, which is on this side of the line, to test it. So that means 0 is greater than or equal to 2 times 0 plus 1. Is indeed 0 greater than or equal to 0 plus 1? Or is 0 greater than or equal to 1? The answer is no. So 0, 0, which sits on this side, is not a part of the solution. It is not a part of the solution. So that means my solution lies over here. So I'm just going to shade this side over here. So that's the sketch of that graph. All right. Again, just to review, I don't know if I have time for another. Let me try another. Let me do an example. We can do, I don't know. What about something like x equals 5? Sorry, x is less than 5. So then, let me sketch my line. My line is x is less than 5. I should think about that as x equals 5. The line x equals 5. Right? So if x is equal to 5, then that means no matter what, at 5, all of my values will be there. And so that's going to give me a vertical line. But that's not right, because if I take a look at what I actually have here, I don't have a solid line, because it's not included. So at x equals 5, I would do that. And then I just need to find any x's that are less than 5. That's anything over here. And so I would end up shading this side. All right, so that's for a vertical line. And we can do something similar for horizontal.